Hello, checking, testing. Hopefully, you guys should be able to hear me now. Welcome to the stream. I'm just going to be starting real soon. I'm just setting this up so that we are at an airfield. As of now, we're initially just going to be sitting on the ground, and while we're sitting on ground, we'll just go through the charts, how to read them, the different charts that are available for an airport. So let's go to Bangalore or Bengaluru. We'll take any parking spot. Welcome everyone who's just joined in. Best pilot ever. Thank you very much. Way too kind. It would be nice if you were able to fly on my flight at some time, but that didn't happen. Our airline didn't let us. But anyway, hopefully sometime in the future. Welcome to the stream. Let's just load in. I'm gonna try and use the Navigraph in-game option so that you guys can see what the charts are. Otherwise, I'm gonna actually have to find one. I don't know why it doesn't show Navigraph on my charts over there. We're just setting this up really quickly so that this works on stream. Hopefully, fingers crossed, you guys will be able to see the charts. Please work. I've got to sign in here. 1 second. I know they should have this set to auto sign in. For some reason, I've got to do this every time I want to use the inbuilt feature for Navigraph. So we'll just quickly get this ready. One thing you would have noticed is these are Navigraph charts. Now, actually, they're the same as the Jeppesen charts in all. I mean, for flight sims, it's the same. They're not updated as frequently, and basically, it's not to be used in the real world. This is meant for flight sim and flight sim only. But for the purposes of learning how to read charts, they're very useful. Now, I am not able to share the charts that we get access to the Jeppesen charts because that is provided by the company. So that is not, I'm not legally really allowed to do that. But let's just go. We're in Bangalore now. Let's just set Bangalore as our airport. Hopefully it's all running well. I hope it's not lagging too much. Link on the Instagram is for the other video. That's not been changed yet, huh? Alright, I'll make an update for this. Uh, where are you flying to today? Today is actually, I mean, initially we're not flying because I put up the options asking whether we should be doing stall recovery or how to read Jeppesen chart, and almost everyone has asked for, I mean, about 60% of the people voted for Jeppesen charts. So I think we'll be doing that today, just quickly running through how to read through these Jeppesen charts. And at the end of that, if we're able, uh, we'll be able to go for a flight and both showcase stall recovery as well as how to actually fly these Jeppesen charts. I'm just making that quick update to the story. There we go. Update is made. All right, let's start. So welcome again to the stream. Hope everyone's doing well. Hope everyone's doing safe. As you can see right now, we're currently in Bangalore, or some sort of Bangalore at least, and we parked at the gate. We're just gonna use this airport for reference today, and we'll show you how the charts line up with the runways, the procedures, the taxiways, all of that. Now, one thing to keep in mind is in the game, not all of the taxiways are numbered properly, or lettered properly rather. But in the charts, they will be. They're pretty accurate. They're not updated as frequently as they are in real life, but for all purposes, all our purposes in the sim, this is more than sufficient. So let's just expand this up a little so that you guys can see a little better. And let's again open up Bangalore. So VOBL is the ICAO identifier for Kempegowda International Airport. V is the first letter that we use in India. Uh, V is also used, actually, it is used in all previous colony states. Could you make the window bigger? Is this big enough, or would you like it even larger? So even places like Australia start with the letter V because these are all Victorian colonies from the past. So that is actually why we have V. O is for our FIR. So actually, if you see on this map over here, you can see that India is divided into a few different FIRs, right, which is flight information regions. Basically, you see this green line, this border line. Uh, just let me know if the mouse is actually following the line properly because I'm not sure if my cursor is actually perfectly lined up. So if it's not, do let me know. But if it makes sense, all well and good. So you can see it's written over here Chennai FIR, right? And on the right side, or on the eastern side, and on the left side over here, this is Mumbai FIR. So basically, this entire region of airspace is controlled by Chennai, and this left-hand side, this entire airspace is controlled by Mumbai, this entire FIR region. If you go to the north, we have Delhi, right? And if you go to the east, we have Calcutta. Now, we also have Guwahati, but that is a sub-FIR. It is actually a part of Calcutta, uh, but which is here in the northeastern side. Uh, but it is a sub-FIR. Majorly in India, we've got 4 FIRs that we work with. Let me just see that everything's all good. All right. So continuing on, let's right now we are in the Chennai FIR. Bangalore is situated in the Chennai FIR, and your airspace is divided like a cake, like an upside down wedding cake, right? Uh, at high altitudes, you are uh, looked after by Chennai. As you start descending and you enter airspace in closer proximity to your airport, that cake becomes smaller and smaller. That size of the airspace that is controlled becomes smaller, and that is handed over from Chennai, in this case, to say Bangalore control, which is Bangalore radar, right? Who will control your aircraft up till I think it's 26,000 feet. So from or is it 25,000 feet? From somewhere around 15,000 feet till 25,000 feet, if I remember correctly. It's not marked here exactly, but yeah, that cake, I'll show you a slice of it once I'll show you how to find that information as soon as I find that marking. But as of now, let's get closer to Bangalore. All right. So we're just going to click here in Bangalore and we're going to click this button to bring up all of our charts. Now, whenever you actually go to an airfield, the first thing you have are all of your reference charts. This gives you a lot of information. In Navigraph, they've only given you the radar minimum altitudes. This basically is the minimum altitude at which the ATC will give you radar vectors, give you headings, and this altitude is decided to keep you safe of the highest terrain around the airfield. If you see on this map over here, you see there's this big arrow and it says 4830. That's the highest terrain in this within 30 nautical miles. 30 nautical miles is approximately 55 kilometers or 56 kilometers actually. So from the center of the airport, within 56 kilometers radius, this is the highest obstacle we have around. And this is Nandi Hills. If we actually look at it in the sim, let's just take a look. You can see it right there. That mountain over here, those are the Nandi Hills. So with an altitude of, what does it say, 46, this loads up, that's going to take a while. Oh wow, every time you click away it... Alright, let's just go back to reference, open up a radar minimum altitude. So 4830. So the tops of Nandi Hills are at 4830 over here. There we go. I think that's a better view. And otherwise, in the real Jeppesen charts, you have a lot more information that's given in your reference charts. There's quite a bit more. You have your lost communication procedures. You have your standard taxi procedures, low visibility taxi procedures, other points of interest. Say, for example, in Bangalore, when you depart, you automatically change from tower to approach. That information is given in these charts where it tells you. So for someone who's coming into Bangalore for the first time, they will read through these charts and understand what the procedures are over here, which are specific to this airfield. Next up, we'll go towards the taxi charts. Alright, just seeing everyone's on. I'm still audible. Okay. So I'm just cross-checking everything once in a while because last time when we tried the stream, it wasn't going too smoothly. But here we are. So let's go. Alright. So they've given us some of these general airport briefings. So you can see our ATIS frequency is given. We have noise abatement procedures, right? So all of this information, you would go through this the first time you're going to an airfield, and you would understand what the procedures are, what the requirements are. At least once, you should have a good understanding. Now, a lot of this is common in a lot of airfields, right? I mean, to an extent, it is the same thing worded in slightly adjusted for each airfield. So it's not a major change every time, but there are some important pieces of information. For example, this communication failure procedure differs airfield to airfield, right? Although it is quite similar in some of them, you can have a major difference. Or for example, let's say if we go to Mumbai, right? In Mumbai, for your pushback, in these charts, your airport briefing charts, it tells you that there are standard pushback instructions for each runway and each parking stand. So depending on what parking stand you're on, when you contact the air traffic control for pushback, uh, the ATC will just tell you cleared pushback runway 27, for example. Now, what that actually means, whereas say in Bangalore, you would get cleared pushback, say if you were going for runway 27, they would tell you cleared pushback facing east on Lima 1 or Lima 3 or whatever your parking stand and taxiway you have to push back on, what direction you're pushing on to. In case of Mumbai, they will not give you that information. They will just say cleared pushback runway 27. Now, what that actually means is something you should know. If you've gone through the charts, you will have that information presented to you in the form of a table so that you know, okay, for this stand, for this runway, we can expect such and such pushback. Over here, you can see a similar thing where we have taxi routes. So these are your standard taxi routes, right? So what this is telling us is if we land on, say, runway 09 left, and we have to go to stand 91. So you would come over here and you'd see 90 through 93, arrival for 09 left, so 91 is over there. So our standard taxi in would be via Alpha, Bravo 2, and then for Lima 1, Lima 2 or Lima 3 for your stand. For stand 91, it would be Lima 1, right? So this would be your standard taxi in instructions that you can expect. The reason we keep this knowledge is, I mean, of course, the ATC will clarify it for you anytime you need, but situational awareness and reducing RT clutter so that you're not blocking radio transmissions for anyone else, right? So this is basically how most of these charts, the information in these general charts are there. When you're going to an airfield for the first time, it's a good idea to read through this, right? Let's now go down to airport 10-9. Yeah, one more thing that is quite important is this information. You see this number over here. We'll see this information going into detail in charts further ahead. But all of this information, the header of this chart is very important to confirm that you are on the correct chart, you have the correct information, and then you will always cross-check this first with the other pilot and then continue reading what is given in the chart to ensure that everyone is on the same page. Now let's zoom back out. If it lets me, it doesn't seem to want to let me. All right, there we go. This shows you the airport diagram. This is the entire airport layout of Bangalore. Now in the game, they've not actually finished work on 09 right 27 left, the southern runway. So this entire portion is actually not available in the game. They only have the north runway and this apron area. I don't believe they have Bravo 2 either. So you can basically assume it stops over here, the apron, and you go from Bravo 3, Alpha for 27 right or 09 left, wherever, which way you're going. We can see, because of the moving map feature, we have our current location in the game shown on the map. You can turn that off for now. If it will update, doesn't seem to want to update. There we go. All right, so continuing. You can see over here, this shows you a lot of information regarding the overall airport layout. It tells you what the taxiways are, what they are named. For example, you can see Alpha 11 is this link joining the holding point for the runway. It's Alpha 11, Alpha 10, Alpha 90. This is also important. You don't call it Alpha 11 or Alpha 10. It will be Alpha 11, right? You specify exactly letter by letter, number by number to ensure that there's no mix-ups that happen. So you have all of your airport taxiway names placed along as you go along. You see these magenta circles. These have the numbers marked HS1, HS2, HS3. These stand for hotspots. These are locations that just by the design of the airport, there is a high probability, and in the past there have been experiences, so this is why this gets updated every once in a while. There is a high possibility for confusion for the pilots, or taking a wrong turn or something of that sort, uh, for entering someone else's taxiway, for blocking traffic. So for these reasons, these are marked as hotspots. During hotspots, you need to have a heightened sense of awareness, right? Or situational awareness. So when you're taxiing through a hotspot, it is actually meant to be heads up from both pilots at all times. So what that means is you are not looking down, you are not doing any other task, you are not fiddling with your iPad or your paperwork or setting up anything in the cockpit. While you're taxiing through a hotspot, you're both looking out, you're both looking at the taxiway lines, the taxiway markings, the turns that are all around you, and ensuring that you are following the taxiway procedures as told to you by the ATC. This is what hotspots are: HS1, HS2, and so on, these magenta circles. Another bit of information you see is you see the runway name and the orientation. So for example, you see we're given 09 left. So we know that for runway 09 left, it has a bearing of 092 degrees. So what that means is, if you look at this airfield, this is pointing towards north. And this is actually, this shows you the difference between true north and magnetic. But yeah, for now, this is going to be your heading indicated, a magnetic heading indicated on touchdown in line with this runway, right? This is the orientation of your runway. And since it is a straight line, and you know that this is 092, we know without looking at the other side right now that your opposite orientation, 092 is facing the east, the opposite orientation is going to be 180 degrees opposite to that, because it's a straight line. So that's going to be facing the west. So we can add 180 to 092 and we get 272, and if we go to this side, we'll see that for 27 right, our orientation is 272 degrees. Over here again, you can see for 27 left, again it is 272, and for 09 right, it is 092. These are parallel runways. If your orientation is different, they are not parallel runways, right? There are benefits to having parallel runways if they are separated by a certain margin, which is why they are built this way. Now the naming you see is called 09 left and 09 right for this reason. When you are coming in for approach, let's do one thing. If we can just turn this around. All right. So say we're flying in from the bottom up, coming in for approach, right? So in our view, 09 left is on the left, 09 right is on the right, which is why they are named in this certain way. If you have another 09 in the middle of this, that will be called 09 center, or 09 Charlie, 09C will be the naming that is given for it. Another thing you'll notice is I'm calling it 09, not 9. Although places like USA, people, air traffic control and pilots do regularly call it runway 1 left or runway 1 or however it might be. But according to standard RT procedures, especially in India, you don't call it runway 1 or runway 9, you call it runway 09, right? So now let's look at it from the other side for runway 27. If we're coming in now from we will be coming in from the east side. So what this is showing, this number 272, is telling us that when we are coming in for this runway, when we are lined up for this runway, we are flying a heading of 272. 272 is towards the west. So that means we are coming in from the east to the west. I hope I'm making sense. If there's anything I'm saying that is a little confusing for you guys, or you would want me to explain it once again in more detail or in more depth, do let me know, and I'll be glad to go back to any point in the stream and explain anything that you might have missed out. Just quickly checking up on the story to see if people be joining in. All right, it's posted, so all well and good. That's a problem solved there. Let's continue. All right, so let's look for more information that's there in these charts. We've gone through the taxiway names, we've gone through the runway orientation, we've gone through the runway naming. Now, there's a lot more information that's given. You can see over here in bold, we have 13,123 feet. This is the usual length of the runway, right? This black bar that you see, that's the usable length of the runway, which is equal to 4,000 meters. So this runway is a length of 4 kilometers totally. And the same thing you can see down here, the south runway is also at a length of 4 kilometers. Another bit of information you see is over here. It says elevation 3,002 feet. So this elevation is calculated from the mean sea level. How about wind directions? Yes, so wind directions play an important part in determining your runway in use, right? Uh, I'll just do one thing. I'll finish this elevation and I'll come back to your point on wind directions. So here we are talking about elevation. Uh, Elevation is always in terms of altitude from your mean sea level. So currently, this says that 09 left threshold is 3,002 feet above the sea level, right? So on a standard, if you've got your QNH and your pressure data set correctly, you're on touchdown at this threshold, you should be reading 3,002 feet. If you look at the other side, you will see that the elevation for this runway, 27 right, is not the same. In fact, it is 83 feet different. 2919 is 83 feet lower than 3002 feet. What this means is going from on runway 09 left, right, you have a down slope. And when you are on runway 27 right, you have an upslope. Now this plays factors uh, in your landing distance calculation, in your deceleration calculations, in your takeoff distance calculations. Whenever we're doing all of this, upslope, downslope plays a factor. How major it is depends on the elevation change overall between your thresholds and the length of the runway. As you can imagine, if it was 80 feet over a 2-kilometer runway, that would be twice as steep, right? So this is how we use, this is how basically sloping of the runway is calculated. You take an approximate for your charts. So 80 feet, 83 feet, that'll be taken as 100 feet difference, and over 4 kilometers you'd calculate the percentage gradient of the runway and use that in your calculations. When we're doing our calculations on our iPads, our EFPs, this is all calculated for automatically. But otherwise, when you're doing the calculation, you will be given on the top of your landing distance chart, you will be given the upslope value for upslope or downslope value for the runway in use, and you will use that accordingly, fit it into your table and calculate your distance. Now, we got a good question which is asking how about wind directions? So wind directions play a crucial part in determining the runway in use. Whenever you are landing or taking off, right, you want to have headwinds. That is, you want to be flying in the opposite direction of the wind. So what that means is if we are on 09 left, we're coming in for 09 left, our heading is 092. The best winds for us will be 272 degrees, or actually it will be reported by ATC as 092. The way this works is ATC reported winds tell you the direction from which the winds are coming, right? Over here, 092 tells you the direction to which you are pointing. If you continue flying on this heading, you will keep going 092 degrees, right? But when you get ATC reported winds, that is where those winds are coming from. So when the ATC reports winds 092 degrees 5 knots, what that means is your winds are coming from the right to the left, from the east to the west, right? So from 092 degree magnetic towards you at 5 knots of speed. And that is the best situation for you coming in on this runway. Reason for that is the aircraft flies, as you guys would have seen on my Instagram post. The aircraft flies, lift is generated when airflow moves over the wing. Now, how that airflow moves over the wing is irrelevant. What we need is a certain amount of airflow over the wing to generate that amount of lift, right? If we have headwinds, the speed at which we need to move across the ground to get the same amount of air flowing over our wings is less compared to no winds. I'll say that again. If you have, let's actually just go back here. This is our wing, for example, right? So say we need a certain amount of air flowing over this wing at all times. Say, I'm just going to throw a random number. This is not how it works, but just for understanding, say you need 10 molecules of air over the wing within every second, right? Or an hour. We'll say hour so that the calculation, it's easier to understand. So you need 10 molecules of air over the wing every hour. And what that requires is from you, say you need to do 10 kilometers per hour. Basically at 10 kilometers per hour airspeed, you will get 10 molecules of air flowing over your wing. Now, for the lift generated, what you require is that 10 kilometer an hour airspeed. If right now I have headwinds that are blowing at 2 kilometers an hour, right, in towards my aircraft in the correct direction that I would want, I've already got, without my aircraft moving, I've already got an airspeed of 2 kilometers an hour. So to hit that 10 kilometers an hour of airspeed to generate the lift required, I now only need to move forward at 8 kilometers per hour according to the ground. So my ground speed will be lower and I will still generate the lift that I require. When you're coming in for landing, a lower ground speed is good for you, right? Because it means less deceleration work required. It's easier to stop the aircraft. The landing distance required is shorter, so it's safer. You have more of a margin when you're landing on that runway. When you're landing with a tailwind now, because we need 10 kilometers an hour of airflow over the wing, but wind from the left to right is already at Parks Obness. Hello, buddy. Nice to have you here. Thanks for subscribing. Sorry for the break over there. So if we've got tailwinds, right? You've got winds flowing from the left to the right. We need 10 kilometer an hour of wind airspeed over the wing. But because without the aircraft moving, we've got winds going the wrong way at 2 kilometers per hour. To overcome that and to get 10 kilometers an hour the right way that we require to generate the lift, we now need to move 12 kilometers per hour across the ground, which is faster than the airspeed that we're flying, right? So flying into tailwinds, your ground speed will be faster than your airspeed. Flying into headwinds, your ground speed will be lower than your airspeed, your indicated airspeed. This is why we like to fly into the wind for takeoff and landing. Now, if you look at this in terms of cruise, while you're in cruise, you would want to have tailwinds in cruise because you are crossing the ground at a higher speed, right? You are covering your distance to your destination at a higher speed. But then as soon as you come in for landing or for takeoff, you would want to have headwinds to reduce your landing distance required, to increase your safety margins, and to reduce the speed at which you touch down. I hope that clears up the wind directions. Thanks, Govind, for the question. All right, let's now continue on. This is the basics for the airport diagram. I realize I dived into quite a long explanation, for one of the easier charts. So I'm going to try and pick this up a little bit. If you guys would like me to continue in this level of detail, however, feel free to let me know and I'll be glad to continue in this level of details. I'm in no rush otherwise. All right, the same information as we had in that airport diagram, we have over here, but this is more detailed in terms of your parking stands. So this will show you your exact parking stands, and which we didn't have in detail available in this chart. These two put together, you will utilize for your taxi instructions. So say we were pushing back from stand, where are we right now? It's not showing us exactly, but we're probably somewhere around 27, 28 as of now, I'm assuming. So if we push back, actually, let's just take a quick look where is that taxiway over there, the terminal ends. I mean, the marking in the game are not absolutely correct, but from my understanding, that would be Bravo 4, the taxiway we saw. So we are probably parked somewhere around 27 or 28. So say we had to go from here till 09 left, right? So what we would do, or what the ATC would tell us is, clear pushback facing west on Lima 3. So from stand 27, we will push back and we will have a nose facing towards the west. And we see Lima 1, Lima 2, Lima 3. So we will be on this dotted line Lima 3. So we push back here, we'll finish our pushback, we'll start up our engines. Then we'll request taxi. Now the ATC at this point can give us taxi in a few different ways. At this point, we would probably change over to the airport chart over here. Depending on the amount of information you require, you can change charts, right? You see over here Lima 1, Lima 2, Lima 3 is not given. So if you want that information, you can stay on parking stands. But since we are familiar with that and we know we are on Lima 3 and they all continue and join up to the same taxiways, we will continue as per the clearance we would get. So let's assume our clearance is Lima 3, Bravo 4. So you'd go from Lima 3, turn right onto Bravo 4, turn left onto Alpha. You see it's marked Alpha for this parallel taxiway over here. So you would turn left onto Alpha and then you would continue on Alpha till Alpha 11 holding point, runway 09 left. That is your full length holding point. And this is how ATC would give you taxi instructions, right? If you're coming in, I'll give you an example we get for say 27 left. When you land on 27 left, you normally exit the runway via Hotel 6 or Hotel 7 on the right. After vacation, you will turn right onto Hotel. Now the standard taxi in from here is Hotel, and this is the information that the ATC will pass on to you. They will say Hotel 6, right on Hotel, left on Golf 4, right on Golf, and then you would change over to the next controller. From there on, they would guide you Golf, left on Papa, continue, left on Delta. From Delta, they could give you Bravo 1 Charlie, or you would continue on Delta and excuse me, you would continue on Delta. As you can see, from Delta there is a Bravo 1 connection, or you can continue on Delta and join Lima 3, Lima 2, Lima 1, whichever line you are assigned. You can see over here for Lima 1, the connection is actually not through this location. So if you had to go Lima 1, the ATC would tell you Delta, Bravo 1, Charlie, Lima 1, and then you take your further taxi. And this is how you follow taxi instructions as provided to you by the air traffic control. Now let's get into some of the fun stuff, right? SIDS and stars will actually come back to a little later. Let's go through the approach charts because I know this is something that everyone is most interested in. You have at Bangalore, you have the initial approach charts and you have the final approach charts. So for your initial approach, the procedures that you have to follow, and then at the end what you have to follow. For now, we are going to jump directly into the final approach charts. because usually coming into places like Bangalore, you are radar vectored in at the end. And while you are not radar vectored, you are following a standard arrival or a standard instrument departure. So the SIDS and stars that we discussed earlier. So these things will be explained further ahead in detail. We'll come back to that later. So assuming we're being radar vectored, you'll be brought in for your final approach. So let's just run through this chart, which is the most important thing, right? Your approach charts. First things first that you will do is cross check that you have the correct charts, right? How do we do that? First thing you check is you have the name given over here. So it's telling you these are charts for Bengaluru, India, ILS runway 09 left. ILS is the type of approach, instrument landing system. If we go to a VOR, or there we go, let's say VOR runway 09 left. And let's just turn that around. Oh, that's not the final approach. Here we are, fine. So you see now it's given VOR over here. Bangalore, India, VOR runway 09 left. So this is, you need to cross check that you have the correct information for the type of approach you are going to be doing. Let's go back to ILS for now. All right. Another thing you will check is you will check your identifier, VOBL, that's correct. Kempegoda International, all well and good. And your chart number. Now this chart number you will read out to your colleague, right? Your captain or your first officer. You call, I have chart number 11-1 alpha. They will cross check that they have the same chart, which is how you know that, all right, we are both on the same chart. Then you will call her effective from 13th November 2020. So they will cross check that their charts are dated the same so that you know that all the revisions are applicable to both of you. There's no information missing from either one of your charts, right? Say someone's got a newer chart, yours is not updated, then they might have some information there that you don't have, and there could be confusion that's caused. So you will always cross check you have the same chart, you have the correct chart number, and they are effective from the same date. The next thing you will check is your frequencies. When you're reading through charts, you work from the top to the bottom, right? There's a few skips you can do once in a while, but overall you run from the top to the bottom and you don't miss out on anything. You go through all of this information. So next thing you run through is these frequencies. So you will cross check that, okay, all of these frequencies are correct. We know the ATIS is 128. This is the old one actually. It is, right? Or is it 12867? I've blanked out. Wow. It is 12865. It's not the old one. This is correct. This is the ATIS for Bangalore, 128675. My bad. Your approach frequencies. When you're coming in from a long distance, you'll just, it is nice to know what the frequencies that you are going to be contacting next, right? So that you don't end up delaying too much time. When you're giving frequency changeovers, you know what to expect. It's already ready. And as soon as they give it to you, you can change it over. You don't end up wasting time or losing out on information if, say, the other controller is looking for you, they're calling for you. So it is always good to go through this and have an idea of what frequencies you're going to be contacting for your approach, for your tower, after landing on ground. In Bangalore, you don't have an automatic changeover on ground, but in other places you do, right? So as soon as you get off the runway, the tower won't tell you to change over to ground. It is expected that you will automatically change over to ground frequency and they will further give you taxi instructions. But in Bangalore, since an automatic changeover is not given, and that information will be given in your reference charts, since that automatic changeover is not given, you cannot change over to ground until tower advises you to do so. So you just cross check all of these. The next thing you check is this frequency. Localizer frequency, India Bravo Alpha November. Now this 4-digit the 4-letter identifier is your identifier for the localizer frequency or your ILS frequency that you use, right? And the frequency for that is 109.3. Now when you are setting it up in your cockpit, you will cross-check both of these things to ensure that you are tuned to the correct localizer, right? So that you're not flying in an approach, because you could be tuned into another localizer, you could be flying in on 092, tuned in somewhere else completely, and you don't want to be doing that, right? So for that reason, you will cross-check this frequency and this identifier in your setup as soon as when you do the cockpit preparation for the approach. The final approach course 092. This tells you what will be the track that you are flying, what will be the course that you are flying in on when you're coming in for your approach. Next up, 9.4 DME, India Bravo Alpha November. So what that means is that 9.4 nautical miles from your localizer ILS DME, from where this where this instrument is located at. From that distance at 9.4 DME, you have to cross-check that you are at 6,000 feet, mandatory 6,000 feet. And in brackets it says 2998. Now what this 6,000 is your altitude. So like we said, this is your altitude from the mean sea level, right? From the sea level, what is your altitude? 2998 is your absolute height from the ground. Bangalore is at an elevation already of 3,000 feet. If you remember our runway charts, the airport diagram, it was showing runway 09 left is at an airport elevation of 3,002 feet. So if you take the 3,002 away from 6,000, you are left with 2998, and that is how you get your height above the ground. So the brackets, that shows you your height, and the bold letters, the bold numbers show you your altitude. Quick water break, 1 second. If you guys have not had a sip of water, please go ahead and do so. Stay hydrated. Alright, let's continue. ILS DA, and in the bracket it says H. Now this is your decision altitude or your decision height, right? This is the last point at which you will decide to conduct a missed approach at this altitude. And 3205 feet of altitude again is 203 feet of height above the ground level. Now this is for an ILS Cat 1 approach into Bangalore, which is why you have a DA given in this form. When you're doing a Cat 2 or Cat 3, it's done differently. You use radio altimeter and you work off of height, not off of the altitude. But as of now, we will continue with DA. This is what we will punch into our cockpit and setup. And at 320 feet indicated altitude, we need to make a decision on whether or not the runway is visible, runway or the approach lights. If they are visible, we can continue the approach. If they are not visible and we don't meet the criteria, you have to go around. Next up, airport elevation 3002 feet, runway elevation 3002 feet. The airport elevation is a mean elevation there is a reference point for the airport that is decided, right, by the operator of the airport. And from that reference point, whatever the altitude is what is mentioned over here. In our case, the runway elevation for 09 left and the airport elevation coincide, which is why they're given the same over here. But if we go to 27 right, again, it will not coincide. This will be 3002. This will remain 3002, but your runway elevation now you see is 2919. So this is how you can cross-check that is there a difference around the airfield, you know. Let's go back to ILS 09 left where we were discussing. Let's stick to one chart mainly. Alright, and after going through all of these frequencies, this information, you will also first go through, before coming to this missed approach procedure, I like to come down here and go through this box of information, which gives you useful information for you, such as DME required. So now we know that for our aircraft to fly this approach, the ILS 09 left, DME or the distance measuring equipment is required to be functional. If this equipment is not working on your aircraft, you cannot fly this ILS 09 left approach, right? This is a mandatory requirement. Another thing it says is altitude, altimeter is set in hectopascals. in India and in a lot of places, we set it in hectopascals. You'll hear QNH 1013, QNH 1012. That is in hectopascals. If you go to places like USA, this will read in inches of mercury, or it would be written as HG over here, I believe. Over there, they say 29992, which is 29.92 inches of mercury, which is how they measure pressure over in USA, right? And you can use either way, but over here in Bangalore, the ATC gives you information in QNH. So everyone flying into Bangalore will be setting their aircraft according to QNH and hectopascals. So this is good information for especially people flying in from abroad. Say someone is flying in from USA, right? Over there they're flying in inches of mercury, but when they come to Bangalore, they're going to have to change the dial on their aircraft to ensure that it reads in hectopascals, or they can convert it and put it in the same inches of mercury, but normally you would change. Runway elevation is 105 hectopascals given over here. Now again, what this means is each one change of hectopascals is approximately 27 point something feet, approximately. So if you actually multiply this, you will get 3002 feet. So you'll come up to your runway elevation. Transition level is given by the ATC. We'll discuss transition level and transition altitude later on at a later date. But basically, this is when you change over from your QNH, your local airfield QNH, to your standard QNH, or vice versa, right? This information we've cross-checked. Another important bit that we have is over here on the right. This tells you your minimum safe altitude, or your MSA, around your Bravo India Alpha BOR. We see Bravo India Alpha is marked over here at the end of the runway. This is where the VOR, it's another type of what would I say, navigational instrument, right, that is available to us, a nav aid which is available to us, the VOR. So from this center point, within 25 miles in all directions, the circle is for 25 miles normally, within 25 miles in all directions, or rather in this case between 360, so a heading of, if you're over here you have a heading of 360, and if you're over here you have a heading of 205. So on the left side, on the west side, our safe altitude is 6,000 feet. Now if you remember, we had Nandi Hills, which you can see is pointed with this arrow over here, the 4,800 something feet. So keeping the minimum terrain clearance in mind, our minimum safe altitude is 6,000 feet towards the west of the airfield and the west of this VOR. On the right hand side, or on the east of the airfield, between this angle and this angle, which would be 025 degrees and 180 degrees, or radials rather, from this VOR, your safe altitude is 5,500 feet. So it's 500 feet lower than the west side. So if you're coming in for an approach on from the east for these runways, you can actually be stepped down to 5,500, and when you're close enough, you clear the obstacle, they actually step you down to 5,000 feet as well. So this gives you your minimum safe altitude within close proximity of the airfield. Next up, we'll come down here and we'll read through first the caution that's given. So it tells you caution for aircraft departing from runway 09 right during segregated mode for of two runway operations. So that means it is a caution for you when you are landing in this runway. You might have the south runway in use for departure, so you might have close proximity of aircraft, right? These guys departing and us landing when the runways are used in a segregated mode of operation. That is, one of them is being used for landing while one is being used for takeoff to smoothen air traffic flow. This is especially useful information, say you have a missed approach for any reason, right? Now, a lot of the aircraft will depart from here, and from Bangalore, most of your destinations are to the north anyway. So they will depart from here, and after some time, they'll turn left to go north. Now, if you're coming here and you make a missed approach or go around, Your misapproach procedure tells you to go straight ahead and then turn left. So again, you might have a conflict with the aircraft that are departing from here. Although the procedures do keep you clear, but it is good to be safe and keep that in mind. Continuing, another bit of caution that's given is do not mistake Yelahanka Air Base for Kempegoda International Airport, which has similar runway alignment. Expect training flights on ILS runway 27, that is at Yelahanka, and helicopter operations at 700 feet above ground level, so at a height of 700 feet at Yelahanka Aerodrome. We can see over here Yelahanka is marked on this. I don't know why it's showing, yeah, it shouldn't be showing a position. There we go. So you can see Yelahanka Air Force Base is marked over here. This is its location, and it also has a runway orientation of 09 left, sorry, 09 and 27. So this caution is to ensure that because it's a similar runway orientation and quite close to our airfield over here, you don't mistake the two. And also to keep a lookout for low-flying aircraft and training flights that are doing circuits. Usually they'll be doing left-hand circuits as well. So they'll be coming closer towards this side toward our runways. And so your air spaces are quite close, and you do see their aircraft on TCAS quite often, their helicopters as well. So these are things to look out for. All right. Now, once we're done with this box, we'll come back here. We'll just see. This is again telling us at 9.4 DME over here, we will be at, we will intercept our glide path, or we will commence a descent on our glide path and on localizer, that is on our ILS approach for our runway. At 4 DME, we have to check. At 4 DME, we have to make a cross check for India Bravo Alpha November. And this is giving you information again. The same frequency we had over here, India Bravo Alpha November, is at 109.3 frequency and 092 bearing. Now these dots and dashes that you see over here are actually Morse code. If you tune in this frequency, once you tune this in, now in modern aircraft, it cross-checks, it identifies it for you automatically. And you can just check this identifier and see that yes, as long as India Bravo Alpha November is displayed, for example, in the A320 that I fly, I know that it is identified it correctly. But in older aircraft and in some other aircraft that are still flying today as well, when you tune something in, you will automatically cross-check with the Morse code. So you will go through, you will turn on, is this stream? I'm not going to comment on that. I'm sorry about that. Continuing here. So the Morse code that's given. So you will turn on your identifier and you will listen for this Morse code. So you will hear the dots and dashes being beeped out every few seconds. And you will hear for a dot dot dash dot 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 dash dash dot. And once you hear this, the whole pattern, you know that you have correctly identified and you have correctly tuned into this frequency. Next up, again, you have the Bravo India Alpha VOR 116.8. You do the same thing. You will cross-check the frequency with the Morse code if required in your aircraft. Although in an ILS approach, you have this tuned in backup, but you won't really require it now. What it is required for is in case of a missed approach procedure. We'll see that going further ahead, which is why we tune it. All right. Next up, we're done with this box. We're done with the cautions. We're done with the procedure that's shown over here. The other bit of information is all of these dots you see. These are pieces of basically this is terrain around the airfield, or maybe a tower or something which is an obstruction at a height of, at an altitude of 3,488 feet, 3,927 feet. And this is showing you that right off the map, you have the highest obstacle at 4,000 plus feet, which we know as Nandi Hills at 4,800 feet, right? Another thing you see over here is it's giving VOR 185A. This is basically telling you that you have a restricted airspace around this area, which would be for Yelahanka airbase rather. Coming down, now we see that we've got this box that tells you when you are coming in for your approach. Before you intercept the glide path at 9.4 DME, you will be at a platform altitude of 6,000 feet. So you will be flying level at 6,000, and at 9.4 DME, you will intercept the glide slope, which has a 3-degree glide path, right? And thereafter, you will descend down at 3 degrees all the way till your DA or your touchdown. At 4 DME, India Bravo Alpha November, you will check that you are on glide slope, and the way you know that is that you are correctly on glide slope as well, apart from the diamond that you will be checking on your display, of course, will be that you have 4270 reading at 4 DME. This is another cross check. This down over here, sorry, let's finish this. You see this arrow that it breaks off? This is your DA or your decision altitude, which over here we have 3205. This depicts the same point, 3205 altitude. This is the last point at which you will be deciding whether or not you have the runway in sight. If you lose sight of the runway at this point or below this point, you will carry out a go around. You need to have the runway or the landing lights or the approach lights, the approach lights or the runway in sight by this point. Over here, this tells you your ground speed in knots, and to maintain a 3-degree glide path, what needs to be your descent rate in feet per minute. So say you are doing 140 knots of ground speed in approach, you will need to maintain approximately 750 feet per minute of descent to be correctly on your 3-degree glide path throughout your descent. If you're coming in at a higher speed, if you're a heavier aircraft, a larger aircraft, say you're a 747 coming in, I'm not sure what the landing speeds are, but I believe it would be between 150, 160 plus. So then you would be maintaining somewhere around 850, 900 feet per minute descent rate to stay on a 3-degree glide path. Continuing ahead, you have high intensity. What this tells you is in this approach, you have high intensity approach lighting system available, and PAPI or precision approach path indicator available on the left side of your approach. Now what the PAPIs are, they're just 4 lights that give you a visual guidance on your glide slope, not on your glide slope, on your vertical profile. And when it shows you 2 white, 2 red, you are on the correct profile. If it shows you any more whites, that means you're further higher than you need to be. If it shows you any more reds, you're further lower than it needs to be. Next up, it says refer to missed approach above. Now we can go back up to what we had skipped, which is this missed approach procedure, right? And now we can discuss if for any reason we conduct a missed approach, or we don't have the runway in sight over here, we conduct a missed approach. What do we have to do? So the missed approach procedure says first climb straight ahead till climb straight ahead. When passing 3,500 feet, turn left. So we'll be continuing our climb from wherever we've commenced our missed approach, right? You will start your go around, you will continue climbing. Once you start crossing 3,500 feet, you will start a turn left onto radial 027 Bravo India Alpha. Remember how I said we need the VOR tuned in for our missed approach procedure? This is why. So now that we have our correct VOR tuned in, we know that for our missed approach, we need to follow a radial 027 outbound. So once we cross 3,500 feet, we'll start a left turn and come in and intercept this radial and start proceeding outbound on 027. Cross 10 DME Bravo India Alpha at or below 7,000 feet. So in this case, we are continuing our climb. We go 3,500, we continue our climb left, and we climb up till 7,000 feet. If you reach 7,000 feet before 10 DME from Bravo India Alpha, then you need to level off at 7,000 feet. If you reach it after that, then there's no worries. But at 10 DME Bravo India Alpha, you need to be 7,000 feet or below. So in case of a missed approach, our altitude will be set to 7,000 automatically. Then climbing to flight level 85. So crossing 10 DME, we can continue our climb to level 85. Proceeding outbound, now we can see from radial 027, we're proceeding outbound to Begra. So on radial 027, we'll go till the point Begra, and at Begra, join the hold or as directed. Maximum 210 knots. So in this entire missed approach procedure, the maximum speed has to be 210 knots. So you do your flap configuration and everything accordingly to ensure that you are meeting this requirements. At Begra, over here we'll come in and we'll join the hold. In this case, it will be a teardrop entry into the hold. Now, what is a teardrop entry and how you figure out which entry you're making into a hold, how to do holds, is something we'll discuss in a video at a later time. And this is your missed approach procedure. After this, let's come down over here. Straight in landing for runway 09 left. Again, this tells you your DA and your DH, your decision altitude and your decision height. We've already cross-checked that. This is just a reminder for you. And we come down and this tells you your visibility requirements for landing. So for ILS Cat 1 approach for runway 09 left, we will require a 550 meter RVR or runway visual range, right? For a category C or D aircraft. And this is when you have full approach lighting system available. So your high intensity approach lighting system, when this entire system is working, you have 550 meters of visibility required minimum. If this approach lighting system is out, if this is not functional, then the minimum visibility required to fly this approach is 1.2 kilometers, 1,200 meters for your visibility requirements. Another thing that is written over here is RVR is 7. You see there's a 1 mark. So we'll come down here. When RVR 750 meters, when a flight director or autopilot or HUD to DA is not used. So if you're flying completely, say flight directors are not working, your autopilot is not functional, you're flying completely raw data, right? Or you're not using HUD to DA. Actually, I'm not too sure about HUD because we don't have that. So I will not be commenting on that right now, but I'll look into this and get back to you. In these scenarios, your minimal visibility requirements will become 750 meters. Now, these requirements are what is given by Jeppesen and by the regulator. When it comes to your airline, the company might have its own requirements, which will be at most, at the minimum, it will be these requirements, or the company can choose to be more conservative and put higher requirements. So to say that you cannot commence this approach at less than say 700 meters of visibility, RVR. So that will be a more conservative approach to add a larger safety margin. All right, well, that is your ILS approach chart. For now, I think that should cover the basics of this for now. We can do VOR at a later point in time. In a later stream, I will cover VOR as well, and other charts that are required. SIDS and stars will cover as well. But yeah, I hope you found this useful and had learned something. If you did find it useful, do let me know. Do like the video. It's been nice to have you guys here. If you've got any doubts, feel free to ask me at any point. I'll be glad to answer them. But otherwise, I will be ending the stream here for now, and we'll be coming back for future videos where we will fly these approaches and show how you actually fly it. It's all well and good to read the chart and to brief it to your fellow colleague, but when it comes to flying this approach, how do you set it up in the aircraft? How do you follow these constraints? What does it look like from the aircraft? And yeah, I hope you enjoyed. Thanks for joining in, guys. It's been a pleasure. Still, figuring out how this whole streaming system works. So if you've got any advice for me, do let me know. But till then, CVR stories, Thanks for joining in. It's been a pleasure. Take care, stay safe. Bye bye.